Captain, what is this, Spock? We received a transmission from the ship. What? It's an emergency.
Thanks, Scotty.
Sulu, what's going on?
Spock told me there was an emergency. Come with me.
Sir?
Captain, transmission.
The Enterprise appears to have encountered a cluster of unidentified geometric shapes. Fascinating.
Thank you, Spock.
We got a damage report, Captain. It seems only the phasers, the life support, and the scanners are still online. According to our scanners, these are our positions. The Enterprise wants to know how far they are from the unidentified ships. How do we find that distance?
We can use an ancient Vulcan mathematical equation, the Pythagorean theorem. Traditionally, we label the sides A, B, and C. A squared plus B squared equals C squared. In our case, 500 kilometers.
It's a Borg fleet, consisting of various geometric shapes.
Okay. First, we need to find the volume of the Borg cube. Before our scanners went offline, we got the distance of this length to be 2 kilometers long. So because it's a cube, we can multiply this by the length times the width times the height, which means it's 2 times 2 times 2. Ultimately, we'll find out that this is 8 kilometers cubed. This will take 8 photon torpedoes to destroy. Let the ship know.
Up next is the Borg cone. We know its radius is 2 kilometers and its height is 6 kilometers. And if we use the equation pi times r squared times height divided by 3, we should be able to find the volume, meaning we'll know how many torpedoes we have to fire to destroy it. So pi times 2 squared, which is 4 times pi, times 6, all divided by 3 is equal to 25.13. We're going to have to use 25 photon torpedoes to destroy this cone.
The next Borg ship is a trapezoidal prism. To find the volume, first we need to find the area of the trapezoid. To do this, we'll use this equation in the parentheses. A plus B equals 18. Then we'll multiply that by the height, 4, which gives us 72. Then we'll divide that by 2 to find the area. That gives us 36. To find the entire volume, we'll multiply that by the depth. That's 36 times 3. That's 108 cubic kilometers.
Alright, Captain, we finished off the trapezoidal prism. We aren't picking up any more Borg ships. All our scanners are registering now as a small moon-like object about 4 kilometers off our starboard bow.
That's no moon. Activate your shields, Ensign.
We need to hurry. The last Borg ship left is a sphere. Our scanners register a radius of 4 kilometers. I remember how the Academy told me to handle situations like these.
How?
Kill yourself and hope to have a better time in your next life.
No! Never give up. Never surrender.
Captain, I thought you might find this equation useful for dealing with the sphere. I've delved into some ancient Gungan texts by a famous scholar known as Jar Jar Binks. He writes that the equation for a sphere is pi times r cubed times 4 over 3. He said that the radius was 4 kilometers. 4 times pi times 4 all over 3 gives us the volume of 165.3 kilometers. Cubed!
Stardate J3N-73N. While I was on leave with Sulu and Spock, the Enterprise was attacked by a fleet of Borg ships. Despite the intense fight that ensued, the Enterprise was able to pull through, and thanks to the calculations that we did on this planet's surface, we managed to completely annihilate the Borg. We had to calculate the distance from our ship to the enemy ship using Pythagorean theorem, and we calculated the volume of cubes, trapezoidal prisms, cones, and spheres in order to destroy the Borg. Kirk out.
Whatever happened to predictability? The milkman, the paperboy, evening TV. You miss your old familiar friends, but